Okay. Yeah.
And you showed something yesterday about removing all.
Yeah.
So you removed object 2, the reference to object 2. I had a question. Is it possible in Java to actually, like for example in Ruby you can do in place variables? Is it possible to remove a string without removing all of the strings? So for example, just removing the strings that are in object, that are referring to object 2, rather than removing whatever's in object 1, any shared, you know what I mean?
Okay, yeah, I understood that. Yeah, okay. So you want to remove only the items which are in object 2 and not in object 1, right?
That's correct. Any shared items, yes.
Okay, I hope that is something which is remove all, right? Which is, you mean, see, if there are common items in between object 1 and object 2, you want me to remove the common item from object 1 which are in object 2, am I right? Is that what you are asking?
Yeah, so if there's a common item, only removing that item, is it possible to just remove the item from object 2 but still keep the object 1 item?
Yeah. So let me just do this remove. Yeah, so object 1 and object 2, when I run this, yeah, can you see this? It's only roots and mango we got. So whatever was there in object 1 and object 2 which were common got removed, and it was only the thing which is not common retained in object 1.
No, what I actually meant is could we still, for example, could we only just remove the tree and apple that's referring to object 2 but still keep the object 1 tree and apple?
No. Okay, I understood your question. See, here we are actually working on object 1, Ron. We are only working on object 1. Whenever I say object 1 dot remove all, right, it doesn't matter what exactly you are giving here. We are not more concerned on object 2. We are more focused on only object 1. Okay, so what you meant is you wanted to remove only these 2 items, but you want to retain these 2, right?
That's correct.
Yeah, yeah. Which means what you are doing is you are actually clubbing these 2 first, right? You are actually clubbing these 2, which is object 1 and object 2. You are adding up these 2, and then you are trying to remove. Let me just add it first. What you mean is this, I hope. Yeah, if you run this, object 1, right, dot add all of object 2, which is clean up, and okay. Okay, run this up. Why are we getting only this?
Srinath.
Sorry, yeah, Ujjwal. Yeah.
I guess I have understood his question. We just want to replace in the remove all, or instead of object 1, object 2, and object 2, object 1. If you do that, you can means you want to keep all the objects from object 1 and remove.
Well, see, for example, like in languages like Ruby, you can just put an exclamation mark at the end of your variable, because usually when you set a value to a variable, you're making a copy of that string. You're not really referring to the actual object, so you're making a copy. But in Ruby, you can just use an exclamation mark to refer to the same string object. So I wanted to know if it's possible, because he said that the objects are common between object 1 and object 2, and if you invoke a remove all method, then that means it removes the tree and apple objects from both objects. Is that correct?
No. It won't remove from both objects. Yeah, it won't remove from both objects. Yeah, I understood your question. The first thing, let me just iterate through even the second one. Okay, just give me.
Okay.
Yeah. So let us iterate through even the second one. Okay, let me use the same iterator maybe for even the second one. Okay, and let me keep some this out. So here I'm just printing my object 1 after removing all. I'm printing my object 1 and object 2. Fine. Run this. you can see object 2 will be retained as it is. Only things from object 1 will be removed. Now if you don't want to remove object 1, right, what you mean is you want to read in object 1, you want to read in object 2, but you want to get the result out of these two, right?
Yes,
Yep.
exactly.
Okay, fine. So at that time what we can do is you have to create a new array list, but you can do it in this way. That's what I was actually about to do today, which is take it as array list, right, string, let us say obj, let's say new is equal to new array list. Here in this constructor you can mention your obj1, right?
Okay.
I gave one collection here, right? Now what I'll do, I'll just do here obj new dot remove all of my obj2. Now I'll not remove this. Now let us print obj1, let us print obj2, and let us print the next one, which is obj new, right? So iteration 3, let us say, and I'm taking obj3 here. So let me take obj, okay, I just have to print obj2 size. Okay, so everything is fine here. My iteration 3, I'm trying to iterate obj new here, and I want to get the obj new size. Iterator 3 and my iterator 3, perfect. Okay, so let me write this as my obj1 items here, my obj2 items here, and obj new items in here, right? Let me run this. Now you can see everything will be retained. obj1 got retained, obj2 got retained, but only we got the value, intersection value, in obj new. Now we are not making any change on the main objects, but we are getting the result value on the third object, right?
Okay. So compared to Ruby, it's a more intricate process of doing that. Okay. That answered my question. Thank you.
Okay, cool. Fine then. Yeah. Okay, so any more questions, guys, in this? So here, this was the next topic actually, which is multiple constructors here. I just wanted to show here. See here, we have array list of mainly 3 different constructors, which we have seen this one till now, which is direct array list. Now anyways, thanks Ron. This second one is something which is you can actually copy the complete collection item into this. Now what we did is we created a new one, and what we did is we just copied the complete existing into this one. We can do these things in 2 ways. First way is you can just mention everything in here, right, in a collection item, or obviously you can just iterate through this object 1 and fill into this. Both are same, but anyways, as we have inbuilt option being provided, right, then why should we go beyond that, right? Just you can use this one. Now what is this initial capacity? Now here, even in array list, if you want to actually make sure that you want to restrict to some items, right, you can do that. Let me just create a new class. Am I recording? Yes, it's going on. So here, let me take it as let me take linked list now. String, let us say it's obj1, let us say new linked list. Yeah, okay, for linked list you can give any number of things. Okay, let me take it as array list itself. Array list string obj is equal to new array list of m. Let me give initial capacity of 5. Now what does it mean actually? So here let me give few items. Obj dot add of something again. Let us take it as some earth. Obj dot add of sun dot add of moon dot add of star so in here there is one shortcut, guys. You would have seen even if something is jumbled, right, something is like this, it accepts, right? Eclipse accepts everything actually because they are in the complete form with their each and every sentence are correct, which we are actually ending up with semicolon, right? If you want to arrange them, just press on, I always do, you would have wondered like how it is being aligned, right? You can just press on Control Shift and F, it will automatically align everything. Fine, Control Shift and F, right? I always do that whenever you create any method or all. Fine.
These are Control Shift and S.
F, it's Control plus Shift plus F.
Okay.
Okay. Yeah. Okay. So Earth, Moon, Star, or let us say galaxy, something. Now here, what we have done is we have just added 5 items. Okay. Let me iterate through them. Okay. I'll use iterator basically. Right, string, let us say itr is equal to g dot iterator and say while tr dot as next, just say this is outer itr dot next. Yeah. Anyways, there is nothing that new we have written in here. We just taken it 5 capacity and we gave the 5 items into it and we're just running it, right? So you can see that all 5 got accepted. Now let me just catch the exception here. Fine. So let me give one more item in here. Obj dot add of, let us say, some new item which is some 1 2 3 4 something in here. Right? Let me run this up. Yeah, it got added. So it says initial capacity, right? But it is not something which we are actually confining the thing here, right? Initial capacity in the sense it can actually have 5 minimum, which means even if you don't access, even if you have provided only 2, right, and if you try to access 4th one, right, it won't give anything. So let me just show you that. So if you remember in our first class, whenever we gave 2, right, whenever we try to access something called obj dot get of some 8, let us say I'm trying to access my 8, so what happened at that time, you can see that it says exception. Now let me just track some 4th item. Right, it is giving exception here. 4th item, should not give me exception. Get init class. Okay, maybe the behavior has changed in 1.7 maybe. The initial capacity of the list here, it says the initial capacity, so which means it can actually save first 5 items and then actually it can go on. So now it should get something, because it should give something called null, because the capacity is 5 and obviously I can access something called 3rd item, which should give me null. Okay, let me check this out. Okay, let me check this, so why it is not actually taking, and I'll give you the answer tomorrow. Fine, let's not waste time on this now. But initial capacity is something we're actually mentioning the minimum capacity of an array list, right? But even if you don't mention, right, obviously you have something called how many items are there, and then you can iterate through them. You can do that, but I just wanted to show you something called initial capacity. I'll show you that tomorrow, right? Now let's move on with this one more entity today. So yesterday we have seen something called iterator, right, which is this, the same one which we have just copied here. Now we'll see something. Now this has got only feature to move forward, or I can say we can actually trace through iterator only in one direction, right? Now we have one more iterator called list iterator. List iterator, basically this list iterator is again is something which is derived from iterator, right? But using list iterator you can actually pass through the list in both the directions. It is on the next direction and the previous direction too. We'll see how. Let us say obj dot, you have something called list iterator. You can see here, right? You have both the things called iterator here. We have taken this iterator, and we are also taking something called list iterator. Let's see what list iterator do. Now everything is same. Everything is same as such we have in iterator. We have something called list iterator dot as next, right? And you will do something called this out of list iterator dot next, right? It will give you the same. Let me just comment this out so that we'll get only one set of items, right? Yeah, this is something which we have gone forward. Now immediately let us say so now whenever you do this, right, so obviously we know that this list iterator, right, is pointing to the last item now, right, because we have already gone through as next until the end. Now here let us traverse through from end to start. How to do that? So here in list iterator you have something called has previous. We have has next, and we have something in list iterator which is has previous. Now this goes in the same way. First, as of now, when we have gone through all these things, right, which means my list iterator will be at the position where it is end of this item. Now whenever we say has previous, we have seen the internal way of running, where when it is at the start, which means it will be before start, right? It will be at the memory location where earth is starting. Then it will go to next, which means it will go to the sun's start, and earth will be returned. In the same way, whenever you do he has previous, right, the pointer will be at the end of 1 2 3 4 memory. Whenever it's a previous, it will go to the galaxy's end, and 1 2 3 4 will be returned, right? It works in the same way. Now let us say, now what you have to do here is you have to do something called previous, right? Previous will give you the item of the previous one. Now again you have few things called list iterator. You can say dot previous index. So you want to know what is a previous index is actually. Whenever before moving to something, you can do that, right? In the same way we have next index too. List iterator next index. Yeah, anyways this index is there also for your previous, right? Let us run this up and you can see. Yeah, now you can see that it was, we were just passing through. Okay, let me just place this at here, right? And previous, let me print this and run. Okay, now you can see 0, 1, sun and all. 5 is 1 2 3 4. Now we have got some 6 items. In the same way you can see it started from -1 because we were in previous, and immediately we are printing previous index, right? And it started from 1 2 3 4, right, and it went till earth, and then when it went to first, right, when it was pointing the first item, the obvious previous will be -1. Why is it? Because previous to first element will always be the -1 element, which is null element. So that's why it just came in, printed -1 and came out. Now you can see that our data is passing from earth to 1 2 3 4 and 1 2 3 4 to earth, right? That is how this next and previous works. Let me just remove this index part and we'll see the index clearly now.
Srinath, this is Purush.
Yeah, Purushottam.
Srinath, can you please explain a bit more on how the index of 1, 2, 3, 4 become 5 to 4 when we give previous?
1, 2, 3, 4 became 5. I'm sorry. What is that?
I mean,
yeah.
When we give iterator dot
Okay.
next, the index of 1, 2, 3, 4 is 5.
Yeah.
But we give in this iterator, when we give dot previous, the same 1, 2, 3, 4 index becomes 4.
No.
So
it don't become 4. No, that okay. I think.
Oh, it's still 5, but
Yeah, it is
the
still
previous
5.
value. Okay, I got it.
Yeah, it is still 5. Next index. Yeah, it is still 5.
Okay.
Yeah, I just wanted to show -1 actually. That's why I just printed previous index at the bottom here, right? I just printed this at the bottom so that I just wanted to show the -1 part. Yeah, this one.
Okay.
Yeah, but anyways, yeah, it was 5 only. Yeah? The index will not change. It won't rearrange something, right?
No.
Yeah,
Okay, got it.
cool. And using this list iterator, right? Let me just do some more things here. So you can actually add the items to direct list, which means the items will be added directly to the list here. Let me add a new item here, right? Let us say something in here, universe, right? And we'll see. Now we have added a new item here, and we'll do something called next and previous now. So I can remove this index part, right? I hope you guys understood how index works. Yeah, fine. Run this out. Now you can see there was one part which we were adding, and then after iterating through, we added something called universe. Now you can see universe got added at the end, right? At the end, because we are printing the items from reverse way, right? So that's why it was actually pointing to the old one, I mean the last one, and then it moved. You can see here you can add any number of them, doesn't matter, it will actually move, it will take that as a last, right? Take one more item here, right? Just say universe 1, or let's say you can also say something universe 2, right? Doesn't matter now. So here you would have seen something here. Whenever we are doing has next, right, it came to end. With now our pointer of this iterator is at 1, 2, 3, 4. Now after this we added few items. Now the pointer of list iterator will automatically move to the next items. If run, you can see here. Now what happens if we add to this object directly? Now let me add few items to object. Dot add.
Stina, this is Purush.
Yeah, Purush. Yeah.
Do we have an option to find the previous value of specific index, like as next of index, something like that? Say I need to find what is the previous value of galaxy. So is there a way?
What is the? You have something called contains.
No,
Yeah.
what I want to know is like using previous, I mean dot previous. Can we identify the previous value of specific index, say index 2 or 3, something like that?
Yeah, you can do that. You can do that. You can do that. See, specific index in the sense you want to directly move to something, or how it is, or how you are saying.
So here, we are printing list iterator dot previous, right?
Yep,
So it
yep.
starts from the last.
Exactly.
So what I want to figure out is like I wanted to have only one value, which is say index 3. Here index 3 is star. So I wanted to know what is the value of previous value of index 3, which is previous value of star, which is moon. So is there a way to find out?
Okay, you want, so you are in star, let us say, and you, okay, which means here you are moving forward, but what you want to print here is once you come to star, you want to print the previous one, right? Is that what you are saying?
Yeah, I don't want to iterate also. I just wanted to. I know the index number, so I just wanted to give the index number and find out what's the previous value of the index.
I think I understood your question. Let me just set. Okay. So you are in. Okay. So unless you pass through star. Now my first question is, how you know that list iterator is at star?
Sorry, Srinath, what is that?
No. You said the list iterator is at star, right? That is what you said, right? Right?
Yeah.
Now, so in order to actually move your list iterator to star, first thing is you have to first move it sometimes, right? Am I right?
Yeah.
No. Okay. Let me just take it in a very low way. No. Before printing all this.
I think if I might chime in, I think I understand what Parush is asking.
Yeah.
If he just wants to, Parush, are you asking whether you could just find out what value index 2 holds? Is that what you're trying to do? Like, if you refer to index 2 just to find out the value contained within the second index?
Yeah.
Yeah, that's all you're trying to do, right? Okay. I think that's all he's trying to do. I don't think he wants to iterate through the list, through the list.
Yeah, actually, the thing is, Purush, I think if I understood correctly, what you wanted is, Ron, I think if he's at star, right? If he's a star, so can he know what is the previous to that? Am I right, Purush?
Yeah.
Yeah. Ron, is that what even you are saying?
No. So the question is, Srinath, this is my question. So forget about the value whatever we have with the index. So I don't worry about the value what is there in the index. So what I want is, I have some index number. I just wanted to know the previous value of index. I know that. I mean, I can directly give like get value of some index number, like index number minus 1.
Yes. You can do that.
This functionality, yeah, we can do that. But using this functionality, so here what we are doing is list iterator dot previous function starts from the last value. So instead
no. It doesn't start from previous value, Purush. It doesn't start. Why it is starting from previous values? Okay. Now I understood your question.
The last value. So what I want is, like, I wanted to give some index number exactly in the parameter or something like that, the index number, so that we can get the previous value of that specific index. Say, I don't know whether it is there or not. My question is, like, say I have list iterator dot previous of some index number, so that say if you are giving index number as 3,
dot here, right? Dot here.
The value more. Yeah, exactly. Yeah.
Okay. You want to move from some index, right? Okay. I understood.
Exactly.
Okay. Maybe something called previous of index. Yeah, I think you have something here.
Oh, we have. Okay.
We have few things. Index of string. Let us say. Let me give something. Okay. Let me take it out first. Okay. You want?
I'm sorry if I have confused everyone.
No, that's fine. That's a good question. Not a problem. Yeah. So in this slide.
I understand.
You're on? Oh, sorry, start. Previous dot index of dot. Oh, okay. One sec dot. Get as previous next index and all. Okay, this will not have that. Okay. Okay, last index. Replace you can get, substring you can get. Okay, no. This previous is actually giving me the object. Right? Okay. No. Whatever we are doing here, dot is on string. you can see this previous is actually giving me string, right? So whatever operation I do here dot is actually on string, not on collection item, right? Now to answer your question, now let us say you want to give one index and you want to get the previous. Is that your question, right? That is your question. Let me create.
Exactly.
Yeah. Let me just create a method for you. I understood your question. Publish. Let us say string you want. Let me create that for you, and let us say get pre-value, and let us say I want to give an array list of string a, let us say a obj list, let us say, right? Here, so what I want to give is list and the int index. Doesn't matter, let me just take few minutes so that I know. Okay, so here let us say I have my string str, right? So what we'll do is, let me create list, right, data. Okay, so here I have a list iterator. Okay, before this let me call that function. Let me call this get. So I have to make it static. Previously all this stuff, let us say obj I'm passing now. Okay, now I'll pass something called 0 1 2 3. Okay. Let me just out of this. Okay, and let me print this value here. One, two, three, four. So we got exception here. Okay, doesn't matter. We are getting exception. This place. One, two, three, four. 0 1 2 0 2 3 4.
Yeah, I think it starts from the last, I believe, Srinath.
Sorry?
Even though we are breaking, I think it looks like it is starting from the last, the previous.
No, actually it should actually start from this point. Okay, let me just print this even. It should not actually. Previous wherever we are actually stopping, right? It should start from that point. Basically it should start from that point actually, but let's see. Okay, it is complete moon. So that's why I see whenever I oh sorry, I'm very sorry, I'm not incrementing this, right? My bad. It was 0 printed. Okay, yeah, you can see star now. Okay, fine. So if it is, let us say, greater than index, maybe break, it will give you the galaxy because it went to, okay. If it is less than, right, because I want to go from at, I'm passing 3 here. Oh, it won't. So my iterator, so when it comes to 0, okay, I printed, fine, 1 2 3. When it came to 3, so when my tracer is equal to 3, I want to break, right? Now when my tracer was 3, it was a star, it was at something called, yeah, let me place this here. Yeah, I'm just writing a small logic here. Let me run this. Yeah, perfect. Now when I was at index, yeah, 3, and I printed that something. Okay, let me just move that to here so that I can print everything. Something tracer. Okay, it will give you the same thing. Now, okay, now it doesn't matter what we are printing, right? It doesn't matter what we are printing here. Now let me run this. Oh sorry, here I just deleted everything. I have to delete on this is out. Run this. I got a moon. Now you can ask the question. I think now we'll do tweaks. Now we want to know 0 1 2, right? We want to know the previous of 2. Let me give 2 here, which means I should get sun, right? You get sun. Let us say I want to know what is the previous of 0 1 2 3 4 5. I want to get a previous of 5. Make your 5 here and see, you'll get galaxy, right? No, the previous will not start from end. Okay, wherever your cursor is, from that place your previous will work. Fine. And obviously you have to write your logic like this, right, in order to get the actual previous value, right, Purush? And there is one more thing in here, which is like if I do something called delete or remove here, right? If I remove here, which means I'm actually removing an item at that place. Let me see what is getting removed here, right? Let me run this. Now we got star. We got star. Can you see this? Why we got star here? Now first let me just comment this up and run. We got galaxy, right? Now here we know that when it got passed through this loop, when it went out of this loop, this pointer was pointing to galaxy, right? And when we removed it, right, it immediately removed the whole galaxy. Am I right? Right? Because it was actually pointing to the next value called galaxy. And when I did previous to this, right, it gave me something called star and not galaxy. Fine. So again, your iterator or list iterator, whenever you remove, right, the current item will be removed. The current latest item will be removed and the next and previous value will be same. That's why we got this as this. When you do something called 1 here, right, let us say when you do 1, which means you are actually want the earth value to be printed. Earth to be printed. Now let me remove that. Let me remove some item. If I run this, we'll see null. Why? Because there is no value beyond earth, right? Which means when we were trying to iterate through this, right, we just stopped at this place. Am I right? We just stopped at this place, and that's why whenever we remove something, this got removed and my sun went to and the sun was at first place. Now what I am trying to do is I am trying to check the first place previous one, which is null. Now if I give in the same way 1 0 1 2, let us say I want the previous value of moon. What should be there? I should get sun, right? But what we are doing when the cursor is at sun, we are calling remove method, which means sun should be removed and it should be printed. If I run this, you can see it will be printed, right? So list iterator will actually work even in between your list, right? Your previous and next will actually work in there. Now in the same way, let me just print previous plus some space and list iterator your next, let us say. I'm just taking the both things here, right? Let me just say this. Now we'll see what exactly it is printing. Let us say I'm giving something called moon here, right, which is 0 1 2, which is 2. Let me run this. Now you can see earth and earth, right? Why? Because our cursor moved to first and then again I'm saying next, right? Both will be same, right? So these are your list iterator works. But previous and next are not from the first and the last, right? You can actually move them wherever you want. Let me give some 0 1 2 3 4 here, right? If I run this, you'll get the same value, moon and moon. Why?
Can you try 0?
Yeah, you want me to give 0?
Yeah, I just wanted to know what is the previous value of null.
It gives 0 will never, it is something like it is never entered into this, it seems, right? When I gave 0 this one, right? Okay, you understood why it is giving galaxy?
Oh yeah, you have incremented before coming.
Exactly, yeah. It parts through all the values, right? And when we made previous, then last value was 1 2 3, right? It just came back to galaxy, and even the next value is galaxy, so that's why it gave galaxy. Yeah,
we don't have to change the code now. I mean, my question is like, what, I mean, for 0th value the value will be null, right, when you are using. So what is the value of previous value of null? So it will crash, right? It will throw some exception.
It will throw,
right?
yeah, perfect, it will throw some.
Okay,
fine. Okay then, so I hope this was clear, right? No,
thanks.
Fine then. So this was something which, so I just commented this part. You can just, I'll share this, you can just uncomment this part and you can just go through this, right? Yeah. So that is all about list iterator, and so this is a complete thing what actually we can do using this complete collections. But anyways, we'll take more examples on different sets and lists again. But this is whatever we have done in all these collections, right? Collection classes, we can do in every collection class. I'm talking about only on list and sets. So whenever I say collection item, right, just remember that I'm just talking about two things: list and sets, right? Which is this. We have just seen these two, right? Under collection, I'm just talking about these things, and I'm not talking about maps. We'll take up a separate thing what map exactly can do. But anyways, there is more resemblance between the collections and maps. We'll see it separately, right now. So that is what is an array list and linked list. Now I hope you understood better how exactly array list and linked list works, right? If you have understood this array list and linked list, just map that to everything. Each and every item of collection works in the same way. Every item will have the same inbuilt methods and all, but few different things. So for that few different things, we have to understand what are the different things. Now let us take it as vector. Now what is a vector? Now vector is again, it is the same collection item as array list, not a linked list. Vector is same as array list. Let me give as vector here. And yeah, okay, let me take a new class maybe, so that calls 5 maybe, and this calls 5. Let me just take this so that I can save some time. Right, so let me call it as vector, and vector here too, and in calls for, let me copy this iterator so that Yeah. So here it works in the same way. You can see that it works completely in the same way. All the methods whatever we have in vector, whatever we have in array list, we have in here. Now there is only one difference between a vector, which is a collection item, and a array list, which is whatever internal methods of vector are there, right? They are all synchronized methods. Each and every method of a vector is synchronized method. If you want to generate some common method which is being used by multiple threads, right, then you can go for vector, right? So that is what this is. So as you have seen something called, if you remember, string buffer and string builder. String buffer is something which acts as a synchronized locked object or synchronized methods inbuilt as such for multiple threads. In the same way here, vector is synchronized one. Now here there is not only, it's a big disadvantage here in this is, even if you are working in a single thread, right, this vector will actually lock the call and it will process it, and then it will give out unless the whole process is done. It won't allow the other to even enter into this item. That's the main disadvantage, because it will completely lock the object, complete the process, and then it will make it out, right? That's why we don't go for vectors if you are actually programming in a single thread there, right? But for multi-threads, yes, correct. But even in multi-threads, why we can use this, or we can just we can use lock the method, right? We have different synchronized methods to actually locking an object. You will never use these type of things to make sure whether it is working in a certain part of your program, right? Because you may not be using only collection items, right? You will be using different things like files and all, and obviously you have to lock the whole program, whole method, or a whole object, right, in order to complete one complete execution of a method and then make other thread to enter into that, right? So that is how the execution works, right? So if you feel that you have only one collection item from where you want to get it, as we have written here, right, in a previous class we wrote one small method to get the previous of something, where I'm just using some small collection item. Maybe there you can use vector. So that is the basic difference between a vector and what we have something called array list, right? But both behave in the same way, right? Even the arrangement, even the internal methods, even the iterators, list iterators, everything works in the same way as our array list, right? So that is nothing but your vector. Now what is the stack? Now again, stack is something which is again a collection item, as same as lists, but there is a small difference in stack. So there is some discipline being provided in stack, which is you should just move in a we have to follow something called stack logic, like which we know that last in first out is a main stack principle, right? And obviously you have to go in the same way. Now how can we make sure that we are actually moving through the items only in stack manner, right? So for that we have some inbuilt methods. Again, let me just copy the same path. Let me just create a new class. So let's call, maybe I'll just give the name itself, stack. Here let me paste stuff, and the declaration part will be same, stack little item, right, and your stack. Now here you can see whatever is there for all collection items, right? You have everything for stack, but it is not allowed to use, it is not recommended to use them. But apart from that, what we have is, we have two important methods in stack which you should use in real time, which is, the first one is something called push. So this, what push will do is, this will add each and every item in a stack manner, right? The first will be sent to the last, and the same way the last one, whatever you actually inserting into stack, will be the latest item, right? The same way, let me just say push here, right? So in this way it just, now here you have something called, when you push something, and now you have to get the values of this. Now let us say I'm doing some, you have one more inbuilt method. So this push is to completely fill your stack, right, with items. Now you have one more item called pop. So pop, what does pop will do is, pop will actually take out the last item, it will remove that item, right, and it will return that the last item out, and the pointer will go to the next item. So that is what the pop will do. Let me just print this is out of obj.size here, and obj.pop. Let me just print this out. Okay, let me run this. You can see here initially the size was 6. When we did pop, right, it just removed this and gave us 1 2 3 4, and then the size was this. And again, if you do pop 3 times, right, what does it mean is we are actually removing the stack items, these 3. Yes, Sakush.
Srinath, why the size is not 5?
Why the size is not 5? It is 5, right?
No, when we start, right? I mean, before popping, the size should be 5. It starts with 0 index, right?
No, size is a number of items, right? You are talking about 0 is index. Index,
okay.
Yeah?
Sorry.
You're talking about maximum index there, right? But I'm talking about number of elements we have, right?
Yeah, I got it.
Okay. So now here what we are doing is we are actually popping 3 times, which means we are actually removing 3 times, right? Now let me show you that. Now you can see here, for initially the size was 6, right? And when we popped it up, the last one removed, and the next last one was galaxy, which means when I pop it again, galaxy came up, and again star came. Now all these 3 items were removed, and then you have something called 3 items left, right? That is what it is, right? And if you do 6 times, let us say, you have popped everything, right? And then see what the size will be. Size will be obviously 0. Now let us say if we do pop one more time, which is obj.pop, right? Obj. Say some up here, right? You can see. Let me just handle that exception. You can see it gave us a null because we have only 6 items, right, and we are actually trying to touch the stack memory for one more item, right? Obviously it won't be there. That's why we just got some error, which is some null here, right? Null exception here. So that is how stack works. And if you are going to use your stack, so this is how you should use it actually, right? Fill the items, and again this will maintain the order. And stack is again an ordered a collection item, right? It will maintain the order, and basically stack is something which you should maintain order if it has to follow the principle called last in first out, right? So this is how your stack works, right? And that is what is that is what we have in complete lists, right? Tomorrow we'll just start up with sets, right? And again sets is same thing. It is same as our array list and linked list. The only difference is that sets will save only unique values. We'll see what happens when we give a non-unique values. We'll see what happens when we give something else non. And again, we'll talk about these two. Hash is something which is same as array, which means the internal arrangement of hash set is something which is in array format, and there is no guarantee of ordered here. And your linked hash set is something which is same as linked list here, right? Which is, it will save the items in a doubly bonded way, and it will keep your order of all the elements in the same way, the way you are adding the items. Which means hash, wherever you see, will act as array. Now again you can see here in maps, you can again you have something called hash map, hash something, and also linked, which is same way. Linked will always maintain order, and other items like hash or array is something which will, there is no guarantee of order rest. Now, and then you have something called the last one, which is sorted. Sorted will always do the same thing. Whatever you add, will be sorted. We'll see these things when we actually come to sets. We'll see how the sorted. In this sorted set is something which is an interface again, right? You have to use under sorted set, you have to use something called tree set, right? Because tree set is directly connected to something called interface called sorted set. The same way the tree map is connected to sorted map. Yeah. So we'll see more on sets first, and before these sets, right? If you want to touch, I can touch on queues first, because this queues is completely comes under something called list, because it will be using ordered lists, right? So we'll first see queues, right? It will be very interesting queues, because in real time you can use these queues for multiple user handling, right? We use a direct Java queues, which is Java.util keys, to actually load some load, to do some load balancing on multiple userness on an application, right? We'll see how this queue works, and we'll generate two things. We'll generate we'll generate multiple threads, right? And we'll see how this queue works. We'll push in some queue, and we'll see how we can actually get it from other, right? We'll do that. Fine then. So let us wind up here, and you guys have any doubts across these two, array list and linked list? Now I hope if you have understood these two, then the whole collection is the same, but with some changes, as we have learned in stack that we can actually pop and push into this. In the same way, we'll see how the link queues works, and we'll see how sets works. Fine.
Ujjwala here.
Yeah, Ujjwala.
Yeah, where do we use vector and stack usually?
Yeah.
What are use cases?
Yeah, stack will be used when you are actually using multiple thread, right? Multi-threading. If you're using multi-threading, right, there we'll be using vectors, because vector is a completely synchronized methods entity, right? And your stack,
So,
yeah.
so is it more effective than array list and linked list?
I wouldn't say effective. See, it is only thread safe. I can say in this way, vector is a thread safe actually. Thread safe in the sense, even if multiple threads are accessing, there won't be any killing up of a program on this, right? So I can say in that way. But both acts in the same way. The objects will never be lost in both array list or vector.
Okay.
Yeah. So that is why, but only mostly people will not be using this vector, because complete thing is a synchronized. But if anything happens, if any execution thing structs at vector item, right, the whole program will be stopped. I mean, the whole program at that thread will be stuck until unless it gets out. The whole program will be on hold at that point. That's the main problem with vector, right? But obviously, yes, if you want to move with the thread safe one, as you have seen something called string buffer. String buffer is something which is thread safe. Same way here, right? You can use this. And stack, I hope you understood where you will be using stack. So wherever you want to put some items, right, and it depends on the same logic, right? So you have a stack, again you are pushing the items. Now you are actually keeping that box with you, and whenever you want to pop items, so wherever you feel that okay, you want to use LIFO, which is last in first out, you can use stack, right? Instead of going through linked list and taking the finding the last index, getting out, you can directly go to stack and get the latest ball, whatever you have placed in your container, right? So that is how you can use stack. Yeah. So that's the two thing. And stack, obviously it all depends on the your requirement, what is the requirement and where exactly you want to use them, right?
Okay.
Yeah.
That's it.
Okay, fine guys, then so let's wind up here. So anyone have any other questions? Purushottam, Ron, Vamshi?
No, thank you.
Yeah, Surender, Shweta. Okay, fine then. So if everything is fine, let's wind up here. Okay, and we'll meet tomorrow and see. Fine.
Thank you.
All right, thank you.
Okay.
All right, bye-bye.
Bye.
Thank you.
Bye.